Chapter 7 Coordinate Geometry. The formulas involved in this chapter are distance formula. Take a line AB with coordinates x1, y1 and x2, y2. The distance between these 2 points is given as AB equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula for distance between 2 points. If we take a point P, let's say this is x, y. Point P is dividing the line AB in the ratio m is to n. Then point P is given as m into x2 plus n into x1 by m plus n. And the y coordinate is m into y2 plus n into y1 by m plus n. So this is called a section formula. For MCQs for the objective type, we can use a shortcut for section formula, which is equals to x1 minus x is to x minus x2, or y1 minus y is to y minus y2. So these are the formulas involved in this chapter. So let us go to the first problem. Let me erase this. The first problem says that the distance of the point P 2, 3 from the x-axis is. So the point 2, 3 is in the first quadrant somewhere here. This is the point. I want the distance of this point from the x-axis. So this is my x-axis. Horizontal line is the x-axis, right? So the distance point from the x-axis will be this distance. This distance equals to 3 units and this distance equals to 2 units. The answer is 3 units now. Option B. Next question is the distance between the point P1, 4 and Q 4, 0 is. So distance PQ equals to, apply the distance formula, x2 minus x1 whole square plus y2 minus y1 whole square. That equals to square root of 1 minus 4 or 4 minus 1 whole square plus 0 minus 4 whole square. That equals to square root of, this is 3 square 9 and this is 16, that equals to root 25, which is equals to plus or minus 5, but distance is always positive, so it's plus 5. So option B. Next question is the points minus 5, 1, 1, P and 4, minus 2 are collinear if the value of P is. 3 points are said to be collinear if they lie on the same line. So A, B, C. These 3 points are said to be collinear if they pass through the same line segment or line. In this case, the points are collinear if the value of P is. We can use 2 methods for this. I can say that if 3 points are collinear, I can say AB plus BC equals to AC. Sum of the 2 distances will be equals to AC. And also the area of triangle. The area of triangle ABC will be equals to 0. So we will take the area of triangle ABC equals to 0. That will be easy. The area of triangle ABC formula is given as delta equals to half of, it is x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is the formula for area of triangle, and this should be equals to 0 for the 3 points to be collinear. And substituting the points, I will get half of x1 is minus 5, so minus 5 into y2 minus y3, so it's pi minus 2, so p minus of minus 2 is p plus 2 plus x2 equals to 1 and y3 minus y1 is minus 2 minus 1, minus 2 minus 1 plus x3 is 4 and y1 minus y2 is 1 minus p. This total expression should be equals to 0. So this equals to, you can send this half to the right hand side, becomes 0, minus 5p minus 10, this is minus 2 minus 1, which is minus 3 into 1 is minus 3, plus 4 into 1 is 4, minus 4p, should be equals to 0. Minus 5p minus 4p is minus 9p, minus 9p, minus 10 minus 4 is minus 13, minus 13 plus 4 is minus 9 equals to 0. So minus 9p equals to 9, p equals to minus 1. So the value of p equals to minus 1. The fourth question is, the area of the triangle ABC with the vertices ABC is, so area of triangle equals to half of x1 into, so it's minus 5 into y2 minus y3. Let me write these points, it will be clear for you. So this is x1 y1, x2 y2, and this is x3 y3. So x1 into y2 minus y3 is minus 5 plus x2 is minus 4, x2 into y3 minus y1, so y3 is 5 minus 7 plus x3 into y1 minus y2 is 7 plus 5. That equals to half of, this is minus 10 into minus 5 is plus 50, minus 4 into 5 minus 7 is minus 2, so plus 8, plus 7 plus 5 is 12, 12 into 4 is 48. That equals to, so this is 58 plus 48. 58 plus 48 gives us 106. 106 by 2 equals to 53. 53 square units is the area of the required triangle. Next question. The distance of the point alpha beta from the origin is, the origin is nothing but O0, 0. Applying the distance formula for these 2 points, distance equals to square root of 0 minus alpha whole square plus 0 minus beta whole square. That equals to root alpha square plus beta square. So the option D is not given, so this is the option D here. It's root alpha square plus beta square. Option D. Next question is sixth one. The area of the triangle whose vertices are A, B and C is. So apply the area of triangle formula. Delta equals to half of x1 y1, x2 y2, x3 y3. So this is x1 is 1 into y2 minus y3, which is 3 plus 4, plus x2 is minus 2, so minus 2 into y3 minus y1 is minus 4 minus 2, plus x3 is minus 3 into y1 minus y2 is 2 minus 3. That equals to half of 7 plus, this is 4 plus 2 equals to 6, 6 into 2 is 12, minus 3 into minus 1 is plus 3. So this is 7 plus 3, 10, 10 plus 12 is 22 by 2 is 11 square units. We will try to do this problem in shortcut manner. I'll tell you one procedure to find this area of triangle. If you imagine that there is a triangle ABC with ABC as vertices, and let's say A is x1 comma y1 and B is x2 comma y2 and C is x3 comma y3, then so area of triangle will be equals to half of, you put the modulus of that here, you start at any one point, start at any one point, let's say B, and come back to the same point in the anti-clockwise. So start at one point B or any point and come back to the same point in the anti-clockwise direction. Here I am starting from B. So write the coordinates of x first, which is x2. Then we're going to C point, which is x3, and then we're touching the x1, which is the vertex A, and then we're coming back to the same point, which is B. So it's x2. So x2, x3, x1, x2. And repeat the same thing for y coordinate. So y2, y3, y1 and y2. That equals to, so don't solve this for variables. If I take numbers, it would be easy for me to do this thing. After writing this, we need to find the det of x2, y3 minus y2, x3. So it's x2, y3 minus x3, y2 plus, do this, x3, y1, y3, x1, x3, y1 minus y3, x1, again plus x1, y2 minus x2, y1, x1, y2 minus x2, y1. So this is the formula. Here, since these are variables, it looks pretty hard for us, but if these are numbers, it's easy for us to understand. We will do this problem in this method now. Here my points are given as A, B, C, nothing but A is given as 1, 2, B is given as minus 2, 3, and C is given as minus 3, minus 4. If I apply the procedure of, so starting with B again, let's say B to B. My x coordinates are minus 2, next C coordinate is minus 3, and then 1, and come back to minus 2. My y coordinates are 3, minus 4, 2, 3. Here I choose B as my first vertex, but it's better if we choose the easiest point. In our question, ABC is a triangle. A is having the points 1, 2, which are simple natural numbers 1, 2. For B and C we have negative numbers, and also they are relatively bigger numbers than the vertex A. So you can start off from the A. This equals to half. Now find this determinant. Minus 2 into minus 4. Minus 2 into minus 4 is 8 plus 8 minus 3 into minus 3, which is minus 9. So minus of minus 9 is plus 9 here. Plus minus 3 into 2 is minus 6 minus 4 into 1 is minus 4. So minus of minus is plus 4. Plus 1 into 2 is 2 minus 2 into 2 is minus 4, which is plus 4. That equals to half. 8 plus 9 is 17. 17 minus 6 is 11. 11 plus 4 is 15. 15 plus 2 is 17. 17 plus 4 is 21. So this should be 22. One, 2, minus 3, minus 2, 3, minus 3, minus 4. So this is 4, minus 2 into minus 4 is plus 8, plus 9, plus minus 6, plus 4, plus 2, plus 4. This 6 minus 6 gets cancelled. So this should be 11 units now. So this is the area of the required triangle. Next question is, The line segment joining the points is trisected. The coordinates of the point of trisection are. The coordinates of point of trisection are. The meaning of trisection is that if I take a line segment AB, we require 2 points for trisection. 2 points divide this AB segment into 3 equal parts. So AB is divided into 3 equal parts by the points P and Q. And this P, Q are said to be the points of trisection. Whenever this P and Q divides into 3 equal parts, there will be 1:1:1 ratio. If I want to find the coordinate P, then P, this is B, this is A, and my ratio is 1:2. The ratio will be 1:2. A is given as 3, -1, and B is given as -6, 5, and we need to find the coordinate P. So apply the section formula for finding the P. So P will be equals to m into x2, that is 1 into -6. So 1 into -6 is -6 plus n into x1. So n into x1 is 2 into 3, which is 6, by m plus n is 3 here. But this is becoming 0. In our options there is no 0 at all. So P is getting coordinate as 0. Even Q is one of the point of trisections. We'll try to find Q next. So Q will be equals to, if I want to find Q, so Q will be having the ratio of 2:1. For P it's 1:2. If I take the coordinate Q here, this will divide in the ratio 2:1. Let me erase this and write clearly. So this is AB, Q is here, which is a ratio of 2:1, 3, -1, and B is -6, 5. So Q will be equals to m into x2, which is 2 into -6 -12, plus n into x1 is 1 into 3 is 3, by 3, comma, repeat the same thing for y coordinate. 2 into y coordinate is 2 into 5 is 10, plus 1 into -1 by 3. So Q will be equals to -12 plus 3 is -9 by 3, which is -3. 10 minus 1 is 9 by 3 is 3. So -3, 3 is one of the point of trisection. For the point of trisections, we get 2 points P and Q. So out of this, Q equals to -3, 3. Next is 8th question. The line 3x plus y minus 9 equals to 0 divides the line segment internally in the ratio. Given AB is the line segment with the points 1, 3 and 2, 7. Now this line is divided by the line 3x plus y minus 9. So another line is passing just like this. This line is dividing the line segment in some ratio m:n, let's say. We need to find the point now. Let's say this point is P. The formula for P is given from the section formula as P equals to m into x2, so 2m, plus n into x1, so n into 1 is n, by m plus n, comma, m into y2 is 7m, plus n into y1 is n into 3, which is 3n by m plus n. This point is lying on the line 3x plus y minus 9. So this line is intersecting this AB line segment. Point P is lying on the line. We can substitute the coordinates of P in this line equation. If I substitute these coordinates, I will get let me write P here. So P will be equals to 2m plus n by m plus n, comma 7m plus 3n by m plus n. So these are the coordinates of P. The line is 3x plus y minus 9. So 3 into, in the place of x, we need to substitute this P coordinate, which is 2m plus n by m plus n. This is 3 into x plus y. Y coordinate is 7m plus 3n by m plus n minus 9 equals to 0. So solve this expression now. Taking the LCM, we will get, this is 6m plus 3n plus 7m plus 3n minus 9m minus 9n. On taking the LCM, we will get this expression. 6m plus 7m is 13m, 13m minus 9m is 4m. So 3n plus 3n is 6n, 6n minus 9n is minus 3n equals to 0. That implies 4m equals to 3n, m by n equals to 3 by 4. So m is to n equals to 3 is to 4 is the ratio. So next is the distance between the points is given as, distance is given as x2 minus x1 whole square. Here x2 is a minus b minus x1 is a plus b. So minus of a plus b becomes minus a minus b whole square plus y2 minus y1 is, y2 is minus a minus b minus y1 is a minus b. On multiplying minus, it becomes minus a plus b whole square. This is plus b minus b gets cancelled, minus a plus a gets cancelled. So this is square root of 2b whole square is 4b square plus this is minus a 4a square. Taking out 4 common, this is 2 into root of a square plus b square. So this is our required solution. Next is 10th question. If a by 3 comma 4 is the midpoint of the line segment joining the points P and R, then the value of A is. So midpoint formula is nothing but midpoint equals to x1 plus x2 by 2 comma y1 plus y2 by 2. We need to find the value of A. Just equate the x coordinate. The midpoint is given as a by 3. Equate this equals to minus 6 minus 2 by 2. That implies a by 3 equals to minus 8 by 2. So this is 2 4 times. A equals to minus 12. Option C. Next question is 11th one. If the distance between the points is 5, the value of k is. So distance formula is root of 3 minus x whole square plus 2 minus of minus 1 is 3 whole square is given as 5. Squaring on both sides. So if you square on both sides, the square and the roots gets cancelled. This is 3 minus x whole square plus 9 equals to 25. That implies 3 minus x whole square equals to 25 minus 9 is 16. So 3 minus x equals to root 16. Root 16 equals to plus or minus 4. If 3 minus x equals to plus 4, x will be equals to minus 1. Or if 3 minus x equals to minus 4, x will be equals to 7. So the answer is 7 or minus 1. 7 or minus 1. Option D. You can just pause the video and do the calculations. Because there are a lot of MCQs, I am just doing it directly. 12th question is the points. So he gave 3 points. We need to check if they are the vertices of an equilateral triangle, or if they are collinear, or if they are isosceles triangle. So let us find the distance of the sides A, B, C. A is 1, 1, B is -2, 7, and C is 3, -3. AB distance equals to square root of -2 -2 -1, x2 minus x1, right? So it's -3 whole square plus 7 minus 1 is 6 whole square, which gives us root of 9 plus 36, which is 45. AB is 45. Let's find BC. BC equals to square root of 3 minus of -2 is 3 plus 2, which is 5 square, plus -3 minus 7 is -10 whole square. So this is 100 plus 25, root 125. Next, AC equals to 3 minus 1 is 2 whole square, plus -3 minus 1 is -4 whole square, that equals to 4 plus 16, which is root 20. So this is root 20, this is root 125, and this is root 45. If they are root values, we can't judge the triangle now. Let us convert these roots into simpler values. I can convert this root 45 as root 45 equals to 9 into 5 is 45. So root 5 into 9. Root 9 is 3, so it's 3 root 5. This value is 3 root 5. Root 125 is 5 into 25. So this is 5 root 5. And root 20 equals to 2 root 5. 2 root 5 plus 3 root 5 gives us 5 root 5. So sum of two sides equals to the other side. These points are said to be collinear because it is possible only if the points A, B, C lie on the same line. So these 3 points are said to be collinear points. So they are neither equilateral triangle or the isosceles triangle. The points are collinear. 13th question. The coordinates of the centroid of the triangle whose vertices are given by these 3 points is, the formula for centroid G equals to, centroid is denoted with letter G, is x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. So this is the formula for centroid of the triangle, that equals to 0 plus 8 plus 8 is 16 by 3. 16 by 3, there is only one option here, which is option D. You can find the y coordinate. 6 plus 12 is 18. 18 by 3 is 6. Two vertices of a triangle are given as 3, -5 and -7, 4. If its centroid is 2, -1, the third vertex is, centroid is given as 2, -1, that equals to x1 plus x2 plus x3 by 3. So 3 minus 7 plus x3 by 3, comma minus 5 plus 4 plus y3 by 3. So equating these two, 2 equals to 7 minus 7 plus 3 is -4 plus x3 by 3. 6 equals to -4 plus x3, that implies x3 equals to 10. Equating the y coordinates, -1 equals to -1 plus y3 by 3. So -3 equals to -1 plus y3. y3 equals to -2. So it's 10, -2. Option C. Option C is the answer. Next question is 15th one. The area of the triangle formed by the points is, we need to find the area of the triangle here. So take the points A, B, C. A is -1.5 or -3 by 2, 3, and B is 6, -2, and C is -3, -4. Delta equals to half of So starting from, let's say, C, or you can start from B. Starting from B and come back to B in anti-clockwise. This is 6 minus 3 minus 3 by 2 and 6, and the y coordinates are minus 2 minus 4 3 minus 2, that equals to half of 6 into minus 4 is minus 24, minus 2 into minus 3 is plus 6, plus 3 into minus 3 is minus 9, minus 3 by 2 into 4 is, this is 3 by 2 into 4 is 6, so minus 6, plus minus 3 by 2 into minus 2 is minus 3, minus 18, that equals to half of minus 30, minus 9, minus 6, minus 3, minus 18. So all are negative values here. Six into minus 4 is minus 24, and 2 into 3 is 6, minus 2 into minus 3 is 6, plus minus 3 into 3 is minus 9, minus 6, plus, okay, this is plus 3, minus 3 by 2 into minus 2 is plus 3, minus 18. So we're getting it as minus 39, minus 39 minus 6 is minus 45, minus 42, minus 42 plus 18 is 60. 60 by 2 equals to 30. So 30 square units is the area of the triangle. I'm sorry, I just took minus 4 here, it's only plus 4. So it becomes plus 24. Plus 30, so this is plus 30, and this is minus 3 by 2 into plus 4 is plus 6, so 36, 39, 39 minus 27 by 2, 39 minus 27. So this is 12 by 2, which gives us 6 units. So the answer is 6 units, 6 square units. 16th question. If the points are collinear, then, so given these 3 points are collinear, then, so we'll apply the area of triangle. Let's say this is x1, y1, x2, y2, and x3, y3. So delta equals to half of x1 is 1 into x1 into y2 minus y3 is 0 minus b, plus x2 is 0, so 0 into anything is 0 here, plus x3 is a, x3 into y1 minus y2, so 2 minus 0. This total equals to 0. That equals to, so sending this 1 by 2 to the right hand side becomes 0, minus b plus 2a equals to 0. So b equals to 2a. So option A is the answer. Next, 17th question. A triangle with vertices is n. So find the distance between these 2 points. Let's say AB equals to square root of minus 1 minus 4 is 5 square is 25 plus 1, that equals to root 26, and BC equals to BC equals to these two points. 3 minus of minus 1 is 4 square is 16, plus 5 minus of minus 1 is 6 square is 36. This equals to root 52. And AC equals to, first and the last point, 3 minus 1 is 1 square is 1 plus 25 is 26. This is root 26 and root 26. 52 equals to root 2 into 26, root 2 into 26. So 26 plus 26, root 26, this gives us 2 root 26. So this is not equilateral triangle, but it is right angle triangle. Root 26 whole square plus root 26 whole square gives us root 52 whole square. So which is satisfying the Pythagoras theorem. So if it is satisfying the Pythagoras theorem, it is right angle triangle. It is option B. Next is 18th question. The points are the vertices of. So instead of solving this, we can plot the graph, approximate graph for this. 4, 0 is here, and minus 4, 0 is here, and 0, 3 is on the y-axis, which is here. This is the y-axis. These two lines are equal, so it is isosceles triangle. A circle drawn with origin as a center, as the center passes through, the point which does not lie on the interior of the circle is. So a circle is drawn with origin as a center. So the options were not here, we'll just skip this question. 20th question. If the distance between the points is 5 units, then the value of P is. So the distance is given as 5 units. So distance formula is root of 4 minus 1 is 3 square is 9 plus P square equals to 5. Squaring on both sides, 9 plus P square equals to 25 and P square equals to 16. So P equals to plus or minus 4. Option B. 21st question. The points are the vertices of a triangle. So find AB, BC and AC and check if they are the points of isosceles triangle or equilateral triangle. If all the sides are equal, it's equilateral triangle. If these two are not satisfying, then go for the condition of right angle triangle. 22nd one. If the segment joining the points subtends a right angle at the origin, then. So is given that AB is a line segment which subtends a right angle at the origin. So if this is the origin, if I take any line segment here, this line segment makes an angle, makes a right angle. So like this angle is right angle here. That indicates point A is A comma B and point B is C comma D. This is 0 comma 0. So A, O, B. I can say that AB square equals to AO square plus OB square. So solving this expression, getting AB square equals to A minus C whole square plus B minus D whole square, that equals to AO square equals to So AO square is nothing but A minus 0 whole square plus 0 minus B whole square, which is A square plus B square, and OB square is C square plus D square. On solving this, here you will get A square plus C square minus 2AC plus B square plus D square minus 2BD. That equals to A square plus B square plus C square plus D square. So these two get cancelled. So at last I have 2AC minus 2AC plus minus 2BD equals to 0. So minus 2AC minus 2BD equals to 0. Taking out minus 2 common, AC plus BD equals to 0. So option B. Next, 23rd question. AOBC is a rectangle whose vertices are given as, the length of its diagonal is given as now. So AOBC is a rectangle. A is given as 0, 3 and origin is 0, 0, B is 5, 0. The length of its diagonal is given by AB or the OC. Since we don't have the fourth vertex, we can find the diagonal using the AB coordinates. So length of AB equals to square root of 5 minus 0 whole square plus 0 minus 3 whole square. That equals to root of 25 plus 9, which is root 34, option C. Next question is 24th. The perimeter of a triangle with vertices is, so we need to find the perimeter. Perimeter of triangle equals to AB plus BC plus AC. So find the distances of all the three sides and just add them. That gives the answer. Next, 25th question. If the distance between the points is 5 units, then the value of P is. So it's the same question. So it's P equals to plus or minus 4. Option B. If P is the midpoint of the line segment joining the points, then the value of A is given as. So the given line segment is QR. So P is the midpoint. The midpoint of P equals to minus 6 minus 2 by 2 and 5 plus 3 by 2. So this is minus 4 comma 8. So P should be equals to here A by 3 comma Y. If P equals to A by 3, A by 3 should be equals to minus 4, A equals to minus 2. So option B. Next, 27th question. If P, Q, R and S are the vertices of the parallelogram, then in a parallelogram, the condition is that if A, B, C, D is a parallelogram, the midpoint of AC will be equals to midpoint of BD, because the midpoint in the parallelogram bisects the diagonals. So midpoint of AC is nothing but, here the given parallelogram is PQRS. We'll rename this. So it's PQRS. Midpoint of PR equals to 5 plus 1 by 2 comma 7 plus 2 by 9. So this is the midpoint of PR. Equate this equals to midpoint of SR, midpoint of SQ, which is A plus 4 by 2 comma B plus 6 by 2. Equate in the corresponding coordinates. 5 plus 1 by 2 equals to A plus 4 by 2. So 6 equals to A plus 4. A equals to 2. and equating the y coordinate, 9 by 9 equals to b plus 6 by 2. This is 1. So 2 equals to b plus 6, b equals to minus 4. So a equals to 2, b equals to minus 4. This is minus 4, option A. Next is 28th question. The point P which divides a line segment joining the points in the ratio 2:3 lies in the quadrant. So AB is the line segment. We need to find the point P. So we need to check the quadrant of P here. The ratio is given as 2:3. A is 2, minus 5 and B is 5, 2. So P will be equals to, apply section formula, m into x2, that is 2 into 5 is 10 plus n into x1 is 3 into 2 is 6 by m plus n is 5, comma 2 into 2 is 4 minus 15 by m plus n is 5. So that equals to 16 by 5, minus 9 by 4. So x coordinate is positive and the y coordinate is negative. So plus, minus. X will be positive and y will be negative in the fourth quadrant. In the fourth quadrant, x is positive and y is negative. So option D. Next question. The points are collinear if. So here we need to find the values of k. Given the 3 points are collinear. So apply the area of triangle. Delta equals to half of x1 into y2 minus y3. x1 is k plus 1 into y2 minus y3. y2 is 3 here and y3 is 2k. So 3 minus 2k plus x2 is 2k plus 1 into y3 minus y1. y3 is 2k minus y1 is 1 plus y3 is x3 is 2k plus 2 into x3 into y1 minus y2, which is 1 minus 3, and equate this equals to 0. This is k plus 1 into 3 is 3k plus 3 minus 2k into this is minus 2k square minus 2k plus this is of the form a plus b into a minus b, which becomes a square minus b square. So that is a square is 4k square minus b square is minus 1. This is minus 2 into 2k plus 2 minus 4k minus 4 equals to 0. Minus 2k square plus 4k square is 2k square. Add the k terms. 3k minus 2k is k. K minus 4k is minus 3k. Adding up the constants. 3 minus 1 is 2. 2 minus 4 is minus 2. That equals to 0. We got a quadratic equation here. Solve this equation by splitting the middle term. Minus 2 into 2 is minus 4. We can split this minus 4 as 4 into minus 1 or minus 4 into 1. Multiplying minus 4 and 1 we get minus 4, and if we add them we'll get minus 3. 2k square minus 4k plus k minus 2 equals to 0. Taking out 2k common here, I'll get k minus 2 and plus 1 common, k minus 2 here. That equals to 0. K minus 2 of 2k plus 1 equals to 0. So k equals to 2 or k equals to minus 1 by 2. So k equals to 2 minus 1 by 2. So in the option B, there is no minus 1 by 2. So option B. Next is the area of the triangle with vertices. So A, B plus C, B comma C. C plus A and C comma A plus B is. So apply the area of triangle formula and just find that. 31st one. The area of the triangle found by the points is so this is 0, 0 and the line is touching the x-axis at A, 0 and B at 0, B. If you notice, this is a right angle triangle with origin as the right angle. Area will be equals to half into base into height, that equals to half of the base is A and the height is B, so half AB. This is the required area of triangle. So here there is no figure, we'll skip this. The vertices were given, we need to find the centroid. Centroid equals to sum of all the x coordinates by 3 and sum of all the y coordinates by 3. So centroid G will be equals to 0 plus 3 plus 0 by 3. So 3 by 3 comma 4 by 3. So it's 1 comma 4 by 3. Next we have direct questions. There are no options here. 34th question. If A equals to A comma 2A and B equals to 1 by A square comma minus 2 by A and S equals to 1 comma 0, then find 1 by SA plus 1 by SB. Let us find SA first. SA will be equals to root of, so 1 minus A whole square plus 0 minus 2A whole square is 4A square. And SB equals to square root of, so SB is 1 minus 1 by A square whole square plus 0 minus of minus 2 by A whole square. So this question involves the addition of reciprocal roots. So we're going to skip this. This is not required for CBSE 10th class. 35th question. Find the distance of a point Px, y from the origin. So this is directly root of x square plus y square. Distance of any point will be equals to the sum of the squares. 37th question. If the distance between the points is 5, then what can be the possible values of k? So distance is given as 5. So apply the distance formula. Root of 1 minus 4 is minus 3 whole square plus 0 minus k is minus k whole square equals to 5. Squaring on both sides, 9 plus k square equals to 25. And k square equals to 16, k equals to plus or minus 4. 39th question. A circle has its center at the origin and a point lies on it. The point lies outside the circle. State whether true or false. So we need to check if this is true or false. The center is at the origin. Center is at the origin now. P 5, 0 lies on it. So this is P 5, 0. 6, 8. The P 5, 0 indicates that 5 is the radius of the circle. So 5, the radius is 5 units. The point Q is 6, 8. The x coordinate is 6, which is more than 5. So definitely the x coordinate is lying outside the circle. So the given statement is true. Next question is 40th question. Find the coordinates of a point A where AB is the diameter of a circle whose center is 2, minus 3 and B is the point given. AB is the diameter given. AB is the diameter and the center is 2, -3. And B is given as the point 1, 4. We need to find A. Let A be x, y. Since AB is the diameter, my center is the midpoint. So midpoint 2, -3 equals to midpoint of AB is x plus 1 by 2, y plus 4 by 2. Equating the x coordinate, 2 equals to x plus 1 by 2 and x plus 1 equals to 4. So x equals to 3. X equals to 3, and equating the y coordinate, -3 equals to y plus 4 by 2, y plus 4 equals to -6, y equals to -10. The A coordinate is 3, -10. So these are few questions from coordinate geometry. We'll see the remaining questions from the remaining chapters in the next videos.